All right, welcome everybody to another Calcoholic video. I'm Andrew, and in this video, we're going to be doing the second order Dirichlet integral. Now, I just posted the video on the first order Dirichlet integral, and the purpose for that was actually for this video. So if you haven't seen that, go watch that video. I won't spoil the solution or the answer, I should say. But yeah, let's just get straight into it. Now, notice this is non-elementary, so we're probably going to be using Leibniz integral rule. Actually, I just lied to you. I'm not going to use Leibniz integral rule. You use Leibniz integral rule for the first order Dirichlet integral, which I already did the solution for in a different video, so go watch that. All right, cool. Now, what I will do is off the jump, I'm going to do integration by parts. So let me say tabular integration. All right, now I need something to differentiate and something to integrate. Something that's, well, really, I have no choice but to choose this sine squared x, because integrating that will be hell. So I'm going to differentiate sine squared, and when I differentiate it, I'll get sine 2x. All right, now when I integrate, what's left is 1 over x, and integrating that is 1 over x squared. Whoops, I flipped these in my brain. 1 over x squared and negative 1 over x. Sorry about that. All right. So now multiply these two together, multiply these two together, and then integrate this second one. So now what implications does this have? Well, if this tabular is correct, then, I just say if and only if this tabular is correct, then the following is true as well. I is equal to, now did I even set this equal to I? No, I didn't. I'll say this is equal to I, just so we have something that's easy to write. I don't have to write it a million times, this large integral. So I is equal to sine squared x over x, negative x, evaluated from x equals negative infinity to x equals positive infinity. All right, and what's left is the integral going from negative infinity to infinity of sine 2x over x dx. All right, cool. Now looking at this over here, let's do some limits in our head. As x get really large, notice the sine squared is bounded between 0 and 1, so we can kind of look at it as a constant because it doesn't go anywhere. And negative x takes over, going to 0. And the same is true for negative infinity. If we go to negative infinity and x is getting arbitrarily large but in the negative direction, we're still getting close to 0. So this entire term here goes to 0. So what implications does this have? Well, it implies that I is equal to 0 plus this integral over here going from negative infinity to infinity of sine 2x over x with respect to x. Now, if you don't believe me, this is the Dirichlet integral that I did in the last video, but we'll make some substitutions to get there first. Now, this implies, and I'll bring that down one so I can write my substitution. I'm going to say let 2x equal t. No, we already have a t. No, I actually don't, because I didn't do Leibniz integral. Okay, cool. Let 2x equal t, which implies that dx equals dt over 2. Okay, cool. Let's make these substitutions. And we have I is equal to the integral. Our bounds have not changed at all. Excuse me. And now what we're left with is sine of t over, if we solve for x, we get t over 2. And then our dx directly substitutes for dt over 2. Now, this 2 and that 2, the 2 under the t and the 2 under the dt cancel out, giving us that I is equal to the integral going from negative infinity to infinity of sine t over t dt. Now, why is this really fascinating to me, and I wanted to make a whole video about it, is because this tells you that the integral going from negative infinity to infinity of sinc squared is exactly equal to the first order, or I should say just the integral of the regular sinc function, sine x over x dx. And of course, in the last video, this is, of course, the famous Dirichlet integral, which we said was pi. So we can make that conclusion. Therefore, the integral going from negative infinity to positive infinity of sine squared x over x squared equals pi. It's really fascinating that the second order and the first order Dirichlet integrals are identical. Cool stuff, cool stuff. All right, thank you for watching. I'll see you guys in the next video. Have a good one.